Hello, everyone. I'm Matt Snyder. We also have Eric Laplatney here. I'm from Microsoft. He works for Wizards of the Coast, a little company you may have heard of. Today we're going to be talking about building scalable, resilient games in Azure through experience that we had there. So I work on a chunk of Azure called Service Fabric, which is going to play a role in here. Now, just to kind of frame everything right, raise your hand if you knew Microsoft had a public cloud. Good, excellent. This is actually pretty good. It's better than I thought it could have been. Keep your hand raised or raise it again if you built something on top of it yourself. Cool, fewer hands, kind of expected. Was it a game? Any games? Awesome, all right. And if it did or didn't go well, we can talk about that more later. I'll be down at the Microsoft booth. Would love to hear the other things that you've built on top of Azure, and if you have any problems, of course, come and talk. One of the things about Azure that is useful, I guess I should stay and point this out. I actually had to update this slide because the data centers in South Africa lit up between when we started making this talk and now. So we had to update this. So one of the things that's useful in the context of games about Azure is the fact that Azure is everywhere, right? We've got 54 worldwide regions, and so you can pretty much get as close, ideally as close as possible to your actual customers who are going to be using your game. And that's important for some classes of games, particularly ones that are latency sensitive. But in general, it's a useful aspect of Azure that we just like to point out. But another thing we like to kind of mention is that Azure is great for games because it has all these different compute options. Now, I'm not even going to get into all the different networking and storage options that are available, but just in terms of compute, you have a lot of options in terms of tailoring, the size and scope of the VMs that you're running on to the game that you're actually trying to get built. And that's actually pretty valuable, right? If you have some sort of batch data processing, there's machines set up specifically for that. If you have a lot of on-disk resources that you need to load quickly, there's storage SKUs optimized and VM SKUs optimized for that. You got machines with lots of RAM. You got machines that specifically have different types of GPUs attached. And so that flexibility really helps you kind of dial in for a particular workload where it runs and how it runs and make sure that that's, you're optimizing for the game that you're building. Another thing that we like to point out is, Azure is a real thing. Some people, AWS is a real competitor, right? But we see a lot of use of Azure in practice. And there's a lot of different types of workloads that run on top of Azure today, right? So this is, you've got discrete manufacturing, you've got IoT scenarios, you've got data streaming and media manipulation. All sorts of things run on Azure. But what about games, right? I didn't see a lot of, the big studios in that prior list, right? Kind of what gives. Well, part of this is that games have unique requirements, and figuring out how to get games up into a public cloud type situation is kind of an active area of work, right? Some people are figuring this out, and the industry as a whole is starting to make this move, but it's a little challenging, right? So latency is a factor, right? You're not running on bespoke custom hardware that's right in front of the user. You might be running remotely, connecting kind of maybe, hopefully not cross-continent, but to an actual data center. HA and failover is a thing, right? Instead of having machines that you control and you're manipulating the maintenance windows and controlling all of that, you're kind of splitting that duty between yourself and the cloud provider, right? And everyone has, ideally, hopefully, no failures, but failures do happen, your code, our code. And how does the game react to that? How does the environment react to that, right? That can be a real factor when building games. Throughput's a concern, right? How do I get the right pipes for all this data and all of these, coupled with the latency requirements, I'm gonna kind of need to do a lot of work to figure out how to say, this is the hot channel for this bulky data, or maybe my telemetry stream. But I have a different set of throughput requirements and latency requirements for the actual game data that's going between the client and the game engine, or between the game engine and the matchmaking services, or between all of this and billing. So figuring out and tuning all of that can be a significant challenge, which brings up naturally that games realistically have multiple components, right? You have lobby, matchmaking, the actual game engine, telemetry, billing, user profiles, all of this stuff exists in this cloud world, and you need to have a way of discovering where those services are, especially given that machines might fail, or you might be doing maintenance, or there's some upgrade going on, right? So that service discovery aspect is a thing. State's a challenge, right? You might not have local storage, or you have limited amounts of local storage. Even if you have local storage, you have to think about things like the HA of that state or data, right? And this, we'll talk a little bit about how different games have different requirements here, but that can be a real challenge, and it can be tricky to mix in with all the other requirements around things like latency. We talked a little bit about failure, and in order to know that you had a failure and react to failures, you kind of have to have some level of health knowledge and monitoring in place, so that as things happen in the environment, you're aware of them, and that ideally the platform underneath you, whatever stack that is, it can react to it, right? So if this instance of the game server goes down, you want to spin another one up or fail over to another one as quickly as possible. But keeping all that stuff HA and running all the time brings up a COGS consideration, right? If you run on these giant VMs that have all these performance tweaks and all of these resources available, they're not cheap. So how do you get the most out of that environment? How do you optimize the environment, not just through picking different sizes or SKUs of VMs, but actually through maybe running multiple workloads on a given machine, or running more or fewer copies of your workload on a given machine, and balancing that COGS aspect with the other goals that you're trying to achieve. And kind of the last thing that we talk about is scaling, right? I mean, that's almost everyone's top question when it comes to hosting games on a cloud like Azure is, hey, how am I going to scale this thing, right? Am I going to scale it by going to another region? Am I going to scale it up by adding more VMs? Am I going to make the VMs larger? Do I scale one service independently of others? How do I make all this work, right? Because as we know in games, your scale is really predictable all the time, right? Everyone knows exactly when something really huge is going to happen in your game environment, or two guilds are going to go to war and just completely destroy a server's resource requirements, right? Things like this are unpredictable, right? Realistically. I'm sure there are some engines out there that have some telemetry over time, but especially with a new game, you have your launch day, and then you have all the other days, and you have no idea really what's going to happen on any of those days. And so scale really comes through as a strong requirement that you have to kind of figure out. Kind of what I mentioned is, and this is just an illustration example, right? Different games, different styles of games have different requirements that push and pull on these vectors in a bunch of different ways, right? So if you're turn-based versus real-time, your requirements around latency and throughput in HA look very different, right? Similarly, if you're premium or freemium, the COGS question, right, comes in earlier, right? And so what's interesting and challenging about getting games working in a public cloud is that no game is really the same. No two games are really alike. They're going to have different mixes of these different patterns. They're going to have different economies. They're going to have different business rules, and they're going to have different requirements in terms of resources. And that really can make it hard for me to stand up here and go like, hey, there's one true answer for how to build games, right? Of course there isn't. As you pick different options here, different things come out, and we would recommend different solutions. Another thing that's different is that building in the cloud is different, right? There's both unique challenges and unique value, right? Challenges we kind of talked about, right? You have the shared infrastructure. You're running on a VM, maybe next to somebody else who's running in another VM. You might be sharing your VM amongst 2 or 3 services that you've got running at the same time. You have virtualized hardware, right? So gone are the days of maybe targeting this particular game's optimized game engine code to particular chunks of hardware and knowing what hardware you're running on top of. You might be running on virtual hardware that it's got a spec, it's got this much RAM, this many cores, but you don't necessarily know that it's this chipset, right? Or it's this vendor, right? That's something that some games have problems with, kind of depending upon how many of those optimizations or even business relationships are baked into the presumption of the game itself. Maintenance controls, right? Well, you want to update your game and you want to roll out new content, but the cloud provider also has to update the cloud provider, right? Our stuff runs sometimes underneath or inside the same VMs that you're using. So now we have this flight control difficulty where if you want a maintenance window at 9 p.m. on Saturday, for whatever reason, and Azure wants to do its maintenance at the same time, that's a challenge, right? We have to coordinate these things and figure out how to roll this stuff out together. All of this, is challenging, but there's also unique value, right? So infrastructure as code is something that we'll talk about a little bit more. Being able to, pick the hardware that is best suited to the game instead of trying to design the game such that it fits and works on this particular set of hardware is really different. And there's also that notion of deferred hardware purchases, right? If the game gets popular, you can effectively acquire more hardware pretty much instantaneously as you are running in production, right? You don't have to go out and make that big server purchase before you even start developing, right? So you can defer that basically as long as you want and hope that you can react to the scale requirements as they change in real time. You get to tailor the environment to the game, and again, to the different parts of the game. So, the matchmaking service probably doesn't need machines with GPUs enabled, right? You can probably skip that. The lobby probably doesn't require SSDs, right, for that really high throughput, right? But the game engine might. And so you can pick and choose the different hardware SKUs and really match them up with the requirements of different components of the game and manage costs and requirements performance-wise that way as well. And one of the big things that we always talk about is that enterprise level support, right? That goes back to the initial slide where there's, all of these companies are betting their businesses on some level of the public cloud. And being able to take advantage of that, having a supported platform and having somebody to call and maybe yell at when things go badly, that's actually a real benefit. And it's something that a lot of people we've seen kind of actually overlook when doing a cost-benefit analysis between kind of running your own hardware or using something like the cloud. So how do you actually do this then, right? If there's all these variables and all these different components, how do you actually build games on Azure? Well, the first challenge is you have to figure out where you want to land on the spectrum, right? On the left, there's like raw VMs, right? This is kind of like, this might look the most like what you use today, right? And on the far right, there's all of these managed services, right? You get functions as a service, or all of the PlayFab stack, or all of these other managed services where you don't really see the infrastructure at all and everything is kind of abstracted and run for you. And there's benefits to both ends of the spectrum, right? On the left, you get a lot of control. It's your environment. It's just like raw machines. You can kind of do whatever you want. And on the far right, you might be able to save huge amounts of time and effort writing code and figuring out how to hook everything together, right? But just like everything, there's trade-offs, right? On the left, you have all that control, but that means you have to go do all the work yourself, right? Which isn't always ideal. There might be parts where you have to, but it's usually a lot of undifferentiated heavy lifting. On the right, you might not have the integration that you need might not be there. You have questions around, are different tools supported? How do I do content delivery? How do I customize this managed service really for me? And so as a result, what we see in practice is that games end up kind of along this spectrum, right? You might have some stuff that you're just going to rent VMs and you're going to do your own work there, and it's basically you're on your own, and you're going to use as much, ideally, of the managed stack as possible, right? So you want to get away from writing as much stuff from scratch as you need to, but there's this Goldilocks zone, right? Where maybe one of these managed services just doesn't work for me, or for my particular game, or for this particular game. And so I have to go write a bunch of custom code, but I don't want to drop all the way down to raw VMs, right? There's just too much work to do down there in order to get things to work. So, clearly, every game is going to be different. You're going to land at different spots along the spectrum. In the rest of this talk, we'll be talking about the particular choices that Wizards made and how they've come up with a successful solution on top of Azure. We'll also be talking about Service Fabric, which is one of the components that they picked to kind of help land in this middle zone, and what tools and aspects of Service Fabric were useful for their game. Now, again, there's all sorts of solutions out there, right? And we want to be very clear that different games will land in different places and that Microsoft supports all of these options no matter what. It's going to come down to your actual requirements, and we always say that we want to make sure that you use the best tool for the job, and we're committed to helping people figure out what that is for the different game options that are out there in the world. So I'm going to briefly talk about Service Fabric. Now, full disclosure, I've worked on the Service Fabric team for about 8 or 9 years at this point, so I love this stuff. I do have a tendency to go on. I'm going to curtail that so that we can get the exciting part of the talk going. But if you want to know more about this thing, just come ask me. I'll be down at the booth. Service Fabric, if you haven't heard of it, is a big platform that we use inside of Microsoft, and it's used to power a lot of the services that you've probably heard of. This is millions of cores of these different workloads, stateless, stateful, high scale, bespoke, running on custom hardware, running in public Azure compute, running on all sorts of different compute environments, running on-prem. And Service Fabric is kind of how Microsoft stands up all these big services and runs them at scale, right? And we've done a bunch of transitions with Service Fabric where we've taken something that was a box product before and we've transitioned it up into a cloud service or a bunch of cloud services. That story plays in really well when we like to talk about games, because a lot of folks who are building games are building and coming from a on-prem box product kind of model and trying to figure out how to lift those things up into a cloud service. So we have a lot of experience in the Service Fabric platform for helping people do this sort of thing. It's just one answer out there. There's a bunch of other orchestrators and platforms that you can build on. This is the one that we use internally. So what makes Service Fabric sensible or a good choice for writing game services? So automatic failure management, right? Service Fabric has HA kind of built in, so you can declare how available you want a particular service, and Service Fabric takes care of making multiple copies of that service, and that if one fails, we know that that's not the desired state anymore, and we stand up a replacement. And that's important to games because downtime of any sort is lost revenue, lost customers, right? Nobody really likes that reconnecting cycle, right? So you want to try and keep the game up and available, and if anything bad does happen, you want to be able to get it back up and running so the customer can use it basically as quickly as possible. Rolling upgrades and health checks. This is something that Service Fabric has baked into the kind of its core around if you want to make changes or Azure is making changes, we want to make sure that those changes are rolled out in a staged fashion and that there's integration with health in the platform so that if anything bad happens during that rollout, the rollout is halted, and that if the issue doesn't self-heal or self-repair, that it rolls back immediately, right? And this lets you change, experiment, move, adapt, and do it in prod without really worrying that you're going to accidentally, blow up the world, right? It's a really powerful capability, and that we see it used for all sorts of things. Dynamic scale and density. So one of the things that Service Fabric does that's a little different is that basically we look at VMs as just a pool of resources, right? And then when you schedule work, when you give Service Fabric a set of services, you can say what type of resources it needs. And a lot of the time what Service Fabric will do is it will pack those services onto the same box. So gone are the days of having the kind of monolithic structure of there's one VM running one workload and that's it, right? Now instead you can have multiple workloads, maybe of the same type, maybe of different types, running on that machine. And that really helps you get dense and deal with different resource requirements while not just blowing up the total number of VMs that you have. That's a cost management strategy, but it's also useful, particularly in games, because you can get very specific about what types of workloads need to run next to each other, right? So if you have latency concerns or chatty components, you can factor them into separate things, but still guarantee that they're going to be running basically in the same process, which is pretty useful. Portability. One of the things that Service Fabric does, because we built it internally to Microsoft and it's been around for so long, is that it basically runs on any computing environment that you want it to run on. So I can say publicly, I have customers on top of Service Fabric on top of AWS, which is a little strange. But it works fine because Service Fabric doesn't care about the compute environment that you run it on. It's not tied to Azure, right? So you can take it, you can run it on top of Azure. We think that that's probably the best place for it. But if you need to, we also have things like Service Fabric Standalone, where you could take Service Fabric and deploy it on bare metal machines in your own data center if you wanted to. And the platform, the capabilities that Service Fabric itself exposes are uniform across all these different environments. Another thing is that Service Fabric supports both Windows and Linux. So if you have a bunch of Linux machines, you can build a Service Fabric cluster out on those just the same, and you get the same features up at the top level. So in cloud, across cloud, on-prem, spanning environments, all of that's kind of assumed in the core platform, and it can be useful in some situations. One of the things that is kind of the last thing that, it's more of a niche scenario, it will depend highly on what your type of game is Service Fabric is unique among orchestrators in that it actually understands stateful workloads. So if we think back to the services that Microsoft builds on top of Service Fabric, you saw things that are like SQL Azure and Cosmos DB, right? So those are big stateful workloads. Those are databases, right? So Service Fabric is the underlying technology that helps do things like replication, leader election, failover, all that stuff, so that those data providers can focus on making great database engines and exposing them as services, right? Why is this useful for games? Well, it's not going to be useful for all games, but for some, it gives you this basically a hot, mutable cache that's right in proc with your actual game engine. And that's particularly useful when we see things like evolving offline worlds, where even when nobody is signed into the game server, something is mutating state and building this world in the background. So when I sign back in, things are different, right? And so you have a place where you can run that stateful computing that's basically built into your game and available for your game, hot, ready, and with all these other considerations around things like failover detection and leader election, just solved and built in. It's not for everybody. I would say, if you can get away with stuffing all your stuff in Cosmos, I would definitely say to do that, right? You don't necessarily want to take on the challenge of running stateful things in production, but if you need to, it is a feature that is there and it is well supported inside of the platform. Another thing where we say, games make sense on top of Service Fabric is because games or chunks of games look like things that Service Fabric already run, right? So if you've got interactive sessions, we've got interactive sessions, right? We've built things like Skype and Teams on top of Service Fabric, right? So if you need to converge in a particular spot and get a bunch of people in one spot and then have them chat or participate in the same game environment, that's something that we know how to do, and we can help you, have your game take advantage of that capability. There's things like stream processing, right? So we've built things like Event Hub and Azure Stream Analytics on top of Service Fabric. So if you've got event triggers, world events, or analytics that's streaming through your environment, Service Fabric knows how to run those types of workloads as well. We mentioned stateful stores, right? Persistent evolving game worlds are the biggest example of this. There are others. I would say that most of those others, if you're talking like profile services or user stats, most of that's going to be better served by being put in a more standard data storage mechanism, blob, table, Cosmos, SQL, something like that. But if you needed to, for some reason, if that was hot, mutable data that needed to be consistent and ready, you could keep it in Service Fabric as a part of your game code and then externalize it when you needed to. And we talk a lot about uptime critical applications. So it turns out that the core of Azure, if you come to Azure and you just ask for one of those virtual machines, the service that's handing out that virtual machine runs on Service Fabric. So clearly, if that service were to have a blip or downtime, that would be bad, right? So we care very much about uptime critical workloads and ensuring that your services stay up and available basically as much as possible, and in spite of random failures or maintenance or things like that. The running joke here is like a lot of people tell you that you can get 5 or 6 nines on a platform, but they don't tell you where the period is, right? So in Service Fabric, we've built a lot of these services that have really high uptime in practice, and we can help explain the best strategies and practices for how to do that. So we kind of talked about all this stuff, right? What are the best practices for any workload that's on top of Azure, but particularly games, right? You want to be practicing those upgrades, because otherwise you're going to lift this thing up into a cloud and you're not going to be able to maintain it or manage it, right? And so we want to be able to roll things kind of generically out there, and that muscle is built and practiced so that you can make these sorts of maintenance changes as you go. We recommend that people shift their workloads as much as possible. If you're not totally greenfield, shift the workloads up into a cloud provider first, then work on modernizing them, breaking them apart into little pieces and factoring them appropriately onto their own machines, then worry about the optimization. We've seen a lot of customers get stuck at the early optimization thing where they think they have to boil the ocean just to get into the cloud, and we want to make sure that people know that that's just not the case. We recommend app-level monitoring and health. A side effect of the fact that many workloads are basically coupled one-to-one with a machine or a VM historically is that people think that VM monitoring is monitoring their workload, and that's not really the case, especially as you start to mix and match your services and run multiple copies of things in the same machine. So getting to a world where the platform understands your app's health and your app's health is described in a very granular manner is really useful, and helps you diagnose and debug a whole bunch of things that you might run into. It also prevents you from making mistakes, right? If you roll out some new feature and you see one of these telemetry streams tank from one of your game services, you can know that you've made a mistake, and the platform can also know that you've made a mistake and roll it back, right? If that's just CPU consumption, then we don't really know, right? CPU consumption went down, is that good? Hard to know. So getting that app level knowledge and exposing that as early as possible is also pretty valuable. We'd like to see people segment the workloads onto different VMs. Again, the VMs come with a variety of hardware options, but also a wide variety of pricing. And so that's going to let you target different chunks of your game at the hardware that's really best for it. It lets you tailor the environment that you're running into the game itself, and really helps kind of over time with both the hard performance requirements and also the hard cost requirements. And we always say use the right compute platform for the job. So if you can get away with using 100% managed services like the whole Azure Game Stack and PlayFab, do that, right? Not all games require you to go and build at this layer, and we'd recommend that you be honest with yourself. Although building stuff at this level is certainly cool, you might not actually need to do it. So if you don't actually need to do it, we recommend that you use kind of the higher order services that are available, specifically because then you get to be abstracted away from a lot of the stuff that you have to deal with when you're down at this layer, right? Failovers should be handled automatically by something like PlayFab, right? Figuring out how to connect two services together should be handled by something like PlayFab and Azure Functions. So you want to try to avoid having to solve these problems yourself, but know that if you do, there are platforms inside of Azure that can help do some of the heavy lifting for you. And we always say, this sounds basic, and as a game industry, you guys are probably more used to this than a lot of folks, but scalability and functional testing as early as possible is critical to know that you're not breaking things and to know that it will work well in a more chaotic, less controlled environment that inherently is the public cloud, right? So you want to make sure that your game is tested and that everything works when, the old Amazon paper used to say, like, when network routes are failing, hard disks are crapping out, and data centers are being destroyed by tornadoes, right? Like, this is real, right? You don't know where things are running, and if something bad happens, that's something your game needs to be able to react to. So we recommend functional testing and chaos testing basically as early in the process as possible to help catch and suss out these issues. Okay, so has anybody actually done this, right? And I saw some hands earlier, so that's great. But for the rest of this, to talk about a game that was actually built on Azure pretty recently, I'm going to bring up Eric from Wizards, and he's going to talk about his experiences building this little game you might have heard of. Thank you, sir.
Thank you.
All right.
That's good stuff, Matt. Thank you.
Tag.
Okay, hi. My name is Eric LaPlatney. I work for Wizards of the Coast as a cloud DevOps, something. And how many people here have heard of Wizards of the Coast? We already did one of these for Microsoft, but okay, cool. How many people here play Magic the Gathering? Wow, and the rest of you have strong romantic relationships, I'm assuming. Well, we built a game. I'll get right to the point. We built a cool game, and I'd like to show you a little of it if I can. Is there a play on here? There it is. Countdown, tick, tick, tock. All time we set things up. So it's going okay. Full disclosure, that is not what the game looks like if you download it. It looks so much better. This is actually a YouTube video I borrowed off the internet for the open beta trailer. I don't know exactly when we're going GA, but it's very soon. Weeks, not days. And it's you can play it right now. I've got it on my laptop here, and it is a thing of beauty. Anyway, we built it we built it 100% in Azure. And that's an important distinction, and I want to talk about that more later. I want to talk about the big movers and shakers, what we basically fought the most on to get this game going. We got 200,000 users so far. Each of those users has, I don't know, give or take, 15 decks. Each of those decks is made from 1,500 unique game-changing cards. And that's 1,500 so far. This is just standard. So all of our game runs on VM scale sets that are running Windows Server 2012 R2 Data Center Edition. Those are being scaled automatically and dynamically using Azure VM scale sets. They're orchestrated by Service Fabric. All of the services in between, we have 25 unique services roughly. All of our state is basically being housed on Cosmos DB, like the wise and handsome Matt advised us to do. And lastly, our whole operational model from stem to stern goes through App Insights. And I want to talk about each of these in some depth so that you can understand why we made the decisions that we made. We have tons of other stuff. Like I said, we are 100% in Azure. All of our operational endpoints are Azure serverless functions because they're so small that we just don't want to care about them. Game and event storage, of course, it's got to live somewhere. Azure events, storage accounts. BI, this is the critical business intelligence events. This is telling you that when I play the cool video, people download the game. When I click on this card, people, I don't know, their eyelids dilate or something, whatever it is. Anyway, we store all that through Azure Event Hub. That transforms and loads that BI data. The VMs themselves, this is showing system events, OS actions. That's going through OMS log analytics. All of our certificates and secrets, that's deployment parameters, passwords, certificate thumbprints, all of that stuff is in Azure Key Vault. To the point where we don't even really have a lot of that stuff. I mean, yeah, we've got a lockbox and it's handcuffed to a guy's wrist, but in my day-to-day use as the engineer building this game, I don't have to look at that stuff. I don't have to have access to that stuff, but I can use that stuff like that. And lastly, all of this is done by Azure Active Directory. We all grew up with Active Directory. It's really cool. It's the best way to make sure that people have access in cohesive, self-described groups, and that they can lose that access at the drop of a hat because they screwed up too bad. It feels like home to us to use the Azure corollary for access to our back end. Now, I talked a lot about the certificate and secret management from Azure Key Vault, but really the beauty of that, the evocation of that technology is here in the VM scale set. We have this cool ARM template, which I'll talk about later, that has an image of our game servers. 6 different VM roles in our architecture, and the certificates that need to be on each individual role make it to the role. The deployment parameters make it there. The environment is tailored perfectly, and then when we need to add more and fewer servers, we just hit the API. I mean, anybody who's made a game in the cloud knows that you can't wait for your processor to get hot. You can't wait for your RAM to get low before you add more servers. It's already too late. So what we do is we call Azure's VM scale set APIs to add these nodes based on synthetic transactions. That's application level monitoring that detects things are getting a little slow, things are getting a little hot, we're bottlenecking at this network card, etc. And then we scale ahead of time so the user experience is just that the game plays. Went too far. Service Fabric. It is extremely hard to sync our game, said every game maker ever, but I'm serious. Like I said, we have about 25 unique services in our architecture. Service Fabric moves these things around. It's like the coolest game of Tetris ever. If you've got a lot of processor on one service and you've got a lot of RAM usage on another service, but they're low in the other categories, it'll just snuggle them right in next to each other and get you the maximum amount of use for your box, which means you're not buying a bunch of VMs just to chase down one memory syncing service, which is really cool. The DNS that Service Fabric uses, the routing of that traffic additionally makes it so that even our devs don't really have to care where the service is. If I want to take you out of a lobby and put you into matchmaking, I don't figure out what IP that's listening on or whatever port. That's dumb. I go to fabric : whack matchmaking service, go and I'm there. It's not really that service name, but yeah, don't write that down. I've made a terrible mistake. Anyway, so it's very easy to get around on the back end thanks to Service Fabric, which takes an enormous boatload off of basically managing the interaction between services that our devs go through on a daily basis. Cosmos DB is, well, it's our state store. We have a lot of cards. We have about a half a terabyte of raw data in Cosmos. I know that's not super impressive, except that we haven't even launched yet, not really. But Magic: The Gathering is played in almost every country on Earth. And in a course of a game, they need to know all of that data several times. And we read about 2,200 polls from Cosmos DB every second from all over the world, and you wouldn't know it because the game is smooth as silk. And lastly, and I think this is the most important, anybody who's put a database on the internet has been scared, and rightly so. The idea that your back-end data has to go out to where AOL lives and then come back in to talk to your mission-critical database is silly. Cosmos DB has us on a secured endpoint so that the private networks of our game services talk through back-end, intranet, Microsoft-only traffic to reach the service endpoint of Cosmos DB and back again. It just doesn't get out of open waters, which means that we can basically trust that Cosmos DB is going to be secure as a service and not have to hire 5 SQL devs just to patch the dumb thing. Lastly, I've got App Insights, and frankly, I don't even know where to begin. We watch everything. We watch hot CPUs, we watch all that BI traffic, we watch every interaction from every service to every other service, networking into the network and out, and it all goes to this, drag and drop, build your own dashboard. And if I were to try to do this on my own, I would have to find an alerting agent that read all of the requisite data off the box. I'd be probably piping my application to some OS-driven event system or something like that. Then I would need something that aggregates it. So now I'm sending to some no man's land box. It's aggregating all of my event data, and then that's going to a master server, and then that's getting realized as a dashboard. And then if I want to make sense of, hey, I played the video, they downloaded the game, I'm putting something else in play to visualize that data. It's just, that's what, like 5 services? None of them are going to be cheap in human suffering or cost, depending on which way you go. But we simply use the appinsights.net library. We send everything we need. OMS plugs right in for the VM data on the back end. It's got visualization involved. And not only that, it's also got predictive, like anticipatory event stuff. It's looking for derivations from the norm. We generally know within about 4 minutes in our experience, with 200,000 users on the boxes, if something's not right. Not necessarily that something's wrong, but that something's different. And I think that's very cool considering the alternatives. ARM templates. I don't know how many folks have wrestled with ARM templates. I consider them to be the unsung, often cursed heroes of the Azure system. And the reason that is because Wizards of the Coast has gone into this DevOps future that everybody seems to embrace so effortlessly. But the fact of the matter is, sometimes your devs sit on that side of the building, and sometimes your engineers who built all the boxes sit on this side of the building, and they just won't talk, and they can be mean about it, like Mean Girls levels mean about it. And when you put all of it into code, all of that infrastructure, all the maps to the servers and the configurations to the database, all into a single cohesive document, I can change a VM for one of my roles to be more powerful, and then I run it over to the devs and I say, look, it's a code review. I'm a dev now, Let's have some fun. I can't understate what an impact that has had. Just being able to have an in-house infrastructure as code that is generated dynamically by the Azure portal, too. I mean, I know that there are alternatives, and I know some of those alternatives are smoke shows. But I can go to my game in Azure right now and click Export Template, and I've got everything I need to redeploy it. Our environments are like beer cans. I mean, you just change the parameters, crush it on your forehead, and throw it in the bin, and I can push out a new one immediately, thanks to the concept of the ARM template. Okay, I feel like I've been super positive at this point. I do want to talk about some gotchas because they lend examples into a larger sort of discipline and a cautionary tale I want to pass on to you. You need to understand the technology that you're interacting with. And you need to understand it on a fundamental level that transcends the marketing material for it and even the first couple of pages of the documentation for it. These are huge, huge pieces of software, and there's very smart people working around the clock to make them the best they can, but it's like an army. Sometimes the left flank doesn't know what the right flank is doing, and that can be a challenge, and information is your ally here. When we started using documents in Cosmos DB, we thought, it's all right. What we'll do is we'll just pull, just the relational data, there's that word, from a card and its user and the deck it's in, and we'll just pull that little tiny subset of the data and we'll act on it, and that read couldn't hurt anybody. It's trivial. And then Microsoft very generously informed us that you get the whole document or you get nothing. It's a NoSQL solution. You get the document, and if you use it like a relational database, then you will overserve. If we'd known that earlier, we would have architected with the concept of hybrid state, maybe using relational where it was appropriate, a little bit earlier. And that's just an example of us not necessarily doing our homework ahead of time. The other one that comes to mind most frequently is the concept of the scale set. So there's the Microsoft scale set team, and these are really good data center guys. They've got their virtualization hosts in the data center, and they're moving this stuff around, and there's an enormous amount of work going on behind the curtain so that I can have 1,000 VMs all scaling individually. And then we've got the service fabric guys like Matt here, and they are taking the output of the scale set stuff, and they're seamlessly installing the firmware for service fabric on top, and they're making all this stuff come online and seamlessly start taking on services, and it all seems like a giant, well-oiled, singular machine, and man, is it not. The scale set guys are working on their thing, trying to make scale sets as good as possible, and the service fabric guys are working to make their stuff as good as possible. And sometimes you run into a problem where scale sets just simply can't have more than 100 nodes in a service fabric solution. So we ended up, late in the game, transitioning our whole model to way more node types. Those are special roles with fewer servers on them and more scale sets themselves. So we're literally in more places in the Azure infrastructure now as a result. And really that's sort of the point. At the end of the day, man, I just want to make games, I don't think that I'm alone in that sentiment. I think that if you're anything like me, you're a child in an adult costume sitting in this room hoping nobody else will notice, and you've tried to make video games before, and what you run into is that there's all these great tools for making video games, but the concessions start almost immediately. I'll worry about monitoring and operationalizing it later, or if the game blows up, well, I'll go to a publisher, and the publisher's got miles of infrastructure stuff that they can take me under their arm, and they can make all of that grown-up stuff happen. If you take nothing else from this talk, well, my talk, I think Matt did really well, just know that the cloud has changed that. We used purely everything in Azure. I mean, yeah, I had a computer in front of me that I wrote code on, but there was no reason for me to feel like there was a component to this AAA video game that I'm intensely proud of, and the team that worked on it that I am more intensely proud of. There's nothing that can't be done at any size of your organization. You don't have to trust that somebody else will do that stuff for you. I think that's a miracle of the cloud, and not even just Azure. It's really cool. Anybody can make games. They don't have to be indie concessions with EGA graphics from 1996 that you pretend were what you wanted in the first place. Just make the game you want, and the cloud's there.